Hi everybody, and welcome to Notes 4.7. In today's notes, we are going to be talking about the quadratic formula. Okay, let's get started and let's review the actual formula itself. Now, you were introduced to the quadratic formula back in Algebra 1. So if you'll recall, you start with an equation in standard form. ax squared plus bx plus c equals 0. Now, if you'll remember, it is super important that you make sure your equation equals 0 prior to substituting in a, b, and c into the quadratic formula. Here's the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you will see that we're going to use the values from the standard form equation up above for our values for a, b, and c. Okay, before we move on to actually evaluating the quadratic formula, let's talk about a key piece of the quadratic formula. And that part is the discriminant. The discriminant is b squared minus 4ac. b squared minus 4ac. So this is the part of the quadratic formula that is underneath the square root. Now notice we did not include the square root. The discriminant is only b squared minus 4ac. Now, by calculating the discriminant only, this gives us two very key pieces of information. It tells us A, how many solutions we're going to have, and B, what type of solutions we're going to have. Okay, so for example, if b squared minus 4ac is greater than 0, meaning it is a positive value, you are going to have two real solutions. So what that means in terms of the graph is that means that my parabola will cross the x-axis twice. Now, if I have b squared minus 4ac equals 0, that means we are going to have one real or double root solution. So for examples, when you solve that, you may get x equals 4 and 4, or x equals negative 2 and negative 2. So really one real solution that repeats itself. Now what that means in terms of the graph is that means the vertex is going to be on the x-axis. So that means the vertex is the x-intercept as well. Now, if b squared minus 4ac is less than 0, if it's less than 0, that means it's going to be negative. And that means that you're going to have two imaginary solutions. So in terms of the graph, what that means is that my parabola will never cross the x-axis. So now let's practice finding the discriminant. Okay, let's look at this first example. It says, how many solutions are there? They want us to determine how many and what type of solutions exist for this equation. So the equation is 2x squared plus 3x plus 4 equals 0. So before I do anything, I need to identify what a, b, and c are. So a is 2, b is 3, c is 4. So since they want to know what type and how many, not what the solution is, so they're not really asking what is the solution, they're saying how many and what type you have, that means I'm going to use the discriminant. So the discriminant is b squared minus 4ac. I'm going to substitute in the values for a, b, and c. Now, if it helps to keep you from making a sign mistake, I always recommend doing plus a negative. Okay, so plus a negative. That way you carry through the negative and you're less likely to make a sign mistake. So 3 squared is 9. Negative 4 times 2 is negative 8. Negative 8 times 4 is negative 32. So that ends up being 9 minus 32. Well, 9 minus 32 is negative 23. So my discriminant is negative 23. Now, since negative 23 is less than 0, that means that there are 0, as in none, no, real solutions. However, there are 2 imaginary solutions. So if it just says how many real solutions, you'd say none. But if it says how many and what type, you would actually say 2 imaginary solutions. All right, let's actually talk about how we use the quadratic formula to solve for x. So remember, the key part of solving any equation, quadratic equation, is that it equals 0. So I have to subtract 4 from each side to make it equal 0. So that turns it into x squared plus 6x minus 4 equals 0. Now, I don't have an a value written, so please remember that that means a equals 1. So what I recommend before you start any quadratic formula problem is that you write the formula. Now, the reason I recommend writing the formula is that because the more you write it, the more it's going to stick in your head, but also, too, it gives you a roadmap as to what values go where. So identify A, B, and C. So A is 1, B is 6, C is negative 4. So now what I'm going to do is I'm going to substitute in 1, 6, and negative 4 for A, B, and C. Well, so now I have the task of cleaning it up. Again, if you need help and you don't want to mess up a sign, I always recommend changing that to plus and negative, so that way you can carry the negative through and you don't end up making a sign mistake. Well, negative times a positive 6 is negative 6. 6 squared is 36. Negative 4 times 1 is negative 4. Negative 4 times negative 4 is 16. And then 2 times 1 is 2. So now all I have left to do is to combine 36 and 16. Now, 52 is not a perfect square. So since 52 is not a perfect square, I have to simplify 52. So 52 is 2 times 26. 26 becomes 2 times 13. So I have a pair of 2's. And if you think about it, 2 times 2 is 4, and the square root of 4 is 2. So that square root simplifies to be negative 6 plus or minus 2 square roots of 13 over 2. Now, if you look at the numbers, not the square root, but at the numbers around it, I have negative 6, 2, and 2. Now, I know that negative 6, 2, and 2 are all reducible by 2. So I divide each of those terms by 2, and I end up with negative 3 plus or minus the square root of 13. Let's do another one. Okay, remember, the first step is always to make sure that it equals 0. So I subtract 2 from each side, and I end up with 4x squared minus 2x minus 2 equals 0. So remember, first step, write your roadmap, write that formula. Then identify what A, B, and C are. So A is 4, B is negative 2, c is negative 2. So now I'm going to substitute those values in for a, b, and c. Okay, now just to keep myself from making a sign mistake, I'm going to do plus a negative for that minus 4 times a times c. So negative 2 becomes positive 2. Negative 2 squared is 4. Negative 4 times 4 is negative 16. Negative 16 times negative 2 is 32. And then 2 times 4 is 8. So now all that's left is I have to combine 4 plus 32. Well, 4 plus 32 is 36. Lucky for me this time, 36 is a perfect square. So the square root of 36 is 6. Now I have to break this into two separate expressions to simplify it. So I have 2 plus 6 divided by 8, and then I have 2 minus 6 divided by 8. So 2 plus 6 is 8. 8 over 8 is 1. 2 minus 6 is negative 4. Negative 4 over 8 is negative 1/2. So when I write my solutions, they are negative 1/2, comma 1. Now I want to make one key point. Never leave your answer in this format. Now if it has a radical, a square root, that's a different story. But because the square root of 36 was a perfect square, we expect you to simplify it all the way out. So again, you're going to have to branch it off, create the two expressions, and simplify. Our next example says x squared plus 4x plus 5 equals 0. So we have to check, does it equal 0 to solve? Yes, it does. So now we're like, wait a minute, we don't have an a value. Oh, wait, we do. It's 1. So now we're going to write our quadratic formula because that's our roadmap as to where everything goes. So we're going to identify a, b, and c. A is 1, b is 4, c is 5. So now I substitute those values into the formula. So negative times positive 4, negative 4. 4 squared is 16. Remember, I'm going to make this plus a negative to not make a sign mistake. So negative 4 times 1 is negative 4, times 5 is negative 20, and 2 times 1 is 2. So now I get negative 4 plus or minus the square root of 16 minus 20 over 2. So all that's left is I need to subtract 16 minus 20. Well, that gets me the square root of negative 4. If you'll remember, back from our imaginary and complex numbers lesson, the square root of 4 is equivalent to the square root of 4 times the square root of negative 1. Well, the square root of 4 is 2, and the square root of negative 1 is I. So we can change that to be negative 4 plus or minus 2i divided by 2. Now, if we'll look at our numbers, negative 4, 2, and 2, they are all divisible by 2. So I'm going to take and do negative 4 divided by 2 is negative 2. 2 divided by 2 is 1. And then over 2, 2 over 2 is 1. So that makes my solution become x equals negative 2 plus or minus I. Okay, so last example. What happens if they turn the tables on us and they tell us to write a quadratic equation with the solutions? So this time they're giving us the solutions and they want to know what the equation is. Well, the first thing I notice is that I have 3 plus the square root of 5 over 2 and 3 minus the square root of 5 over 2. And I'm like, dude, Those are the same equations, except one's plus, one's minus. So the first thing I'm going to do is I'm going to combine that into a combo solution. So I'm going to turn that back into 3 plus or minus the square root of 5 over 2. Step 2 is I'm going to write the quadratic formula right under it. And then I'm just going to match up the parts. So the first thing I notice is that, well, 3 is in the spot of negative b. So I'm going to say negative b equals 3. So that means that b equals negative 3. Then I notice, well, 2 is in the spot of 2a. So that means that 2a equals 2, which means a equals 1. And then lastly, I know that 5 is in the spot of b squared minus 4ac. So I say, okay, b squared minus 4ac is equal to 5. Well, I know b and a, so b is negative 3 and a is 1. So that gives me 9 minus 4c equals 5. I subtract 9 from both sides, and that gives me negative 4c equals negative 4, and that means c is 1. So now that I have a, b, and c, I can substitute those in to the standard form, and I have my equation. X squared minus 3x plus 1. Now you may be wondering, well, a equals 1, do I have to write it? And I'm going to say it doesn't matter. If you had written 1x squared minus 3x plus 1 equals 0, that would be the same as x squared minus 3x plus 1 equals 0. So if your a is 1, that's a matter of personal preference. Both are mathematically correct. All right, so that concludes our lesson. Your homework is worksheet 4.7. So one quick thing, guys, we are still in a pandemic. Do not get tired. Do not give up. Okay? Do not be lackadaisical. Please wash those hands. Wear your mask. Socially distance. And be safe. Be careful. And make great decisions. All right? So we will see you guys back for 4.8. I hope everybody has a great day. And we'll talk to you soon. Bye-bye.